All right, for all those people actually paying attention, your phone is not out in front of you. You have no earbuds in at this current moment in time. So let's go with class.
Yes.
All right, so we're going to finish up 3-5. Then we're going to do a whole lot of test prep. Also, second semester, we already have 2 days booked for Saturdays to come in and do mock test. We have a Saturday and we have an I day already set up. We have to do 3 mock tests in between January and the day of the test. It's yeah, we're gonna do 3 full mock tests. Okay, now, and I will grade it as if it is the actual exam. I have the grading rubric to go by and go down the whole thing for as if it is a whole grade exam. So whatever score you get is comparable to what you might get on the exam. It is pretty straightforward.
For the calculus test, is it the same as the pre-calc where it's like really low, but you need to get.
Yeah, like I think a 40 is a 3. I think like a 40% is a 3 or something like that. Yeah, that's what you're saying? Okay, so let's do this so we can actually focus on getting that because we're going to do that next. We got to finish this first. Now, does everyone have 3.5 right now, especially those people that walked in really late? Wow, seriously, man. I just saw his hair start curling. That was crazy. All right, Newton's method for approximating real zeros of a function. So now, this is probably one of the ones that will pop up on that AP exam. Okay, Newton's method. It's always on there at least once. It's super annoying. Do you guys recall why yesterday I said it was annoying? It's approximated when we could actually go through and find the actual. So we're approximating. So this one right here is going to use finding the real zeros of a function. Okay? So identify these things right here. So I get C1, which is going to be a guess. C1 is a guess. Where C2 is based on what C1 is, and we have iterations of that. So then C3 would have C2 in here. Does that make sense right there? And if it says like C4, which I don't think it'll ever ask for, you would actually have C4 is C3 minus F of C3 over F prime of C3. Okay. Now, application. Let's do this. So the things I actually need is going to be my zeros. And I also need what? I need to find the derivative. So that's important. So I need to start finding derivatives. So I know what f is. So let's say f prime of x is 3x squared plus 2x minus 1. Now, wording is important. A lot of people just look at all these words up here and they just skim them. Wording is important. Find a fourth approximation to the positive real zero of the function. Positive real zero of the function. That means where this here, a function, that function is going to have zeros. That's where it crosses the x-axis, right? And it's positive, real. Okay, so let's start with, since I really don't know what it's going to start off with, it's positive real zero. So is 0 a positive number? No, 0 is not a positive number. It's actually neither negative nor positive. So let's go like this. Start with the number line. F of 0. Because I need to know where it's going to be starting at. If I'm starting at all positive numbers, to find out if it's a 0. Now, what's going to happen, something specific is going to happen if I have a 0. If it crosses, how can I tell that it crossed the x-axis? No, it's not going to have a 0 because we're not finding the 0 right now. We're looking for zeros.
Oh, it would be negative.
What would be negative?
The y values?
Close. Close. You're halfway there. Huh? No. There you go. Positive and negative. It's got to switch in between positive and negative. It's not that it's just negative. It's got to switch between positive and negative. And that's why I'm starting with 0. For those people not on the computers right now, this is actually super important. So it's got to switch. So we have to first start out positive real zeros. Start off here. 0. Plug in 0 for all this. What do I get? Negative 2, right? All right. Now, f of 1. That's going to be, let me see, 1 plus 1 minus 1 minus 2. Negative 1. These are f's. And f of 2. 8 plus 4 minus 2 minus 2. So this is going to give me a positive 8. It crosses where? Between 1 and 2. That's what we're trying to get at here. It's crossing between 1 and 2. So that's where I'm going to go through and start my guess. Like I said, C1 is my guess. What do you want to guess? 1.5. Let's just start right there in the middle. So I'm going to say right here, C1 is 1.5. Now, I'm going to need a little bit more work, so I'm going to another page. So hopefully you got this all written down. Yes? Okay. All right, so I am right here. So C2 is equal to C1 minus f of C1 over f prime of C1. And if you don't have your calculators, you're probably going to need them here in a minute. Now, I'm going to help you guys out. This is a neat trick with this calculator because for people actually paying attention and use their calculator like they're supposed to, these tricks are going to save you a whole lot of time, effort, and headache. Scratch pad. F1, I'm going to put in my original function. Why? Why? Are you threatening him with a pair of pliers? Is he threatening you? He's bullying you. He's got a weapon in his hand now, so I'm kind of worried. Why? Why, Blade? Anyway, so my first function, I'm going to put my function for those people not on their computer or phone. So what was my function? It was x to the third, right?
X to the third plus x squared minus x minus 2.
Okay. Plus x squared minus x minus 2. Good job. I'm going to hit enter. Bam. Hey, look. It is somewhere between there. So couldn't I just use my calculator to find that 0? Yeah. But that's not what we're doing here. We're using Newton's method. Okay, because back in the time of Newton, they didn't have calculators. Hit tab. In my F2, my second function, I'm going to put where my derivative is. My derivative was 3x squared. Was it plus 2x? It was plus 2x. And then like that, right? Okay. Now, I'm not doing this for the graph. I'm doing this to try to be able to try and do a couple other things with this. Hit tab. It's on the left. There you go. And F2. That's what we're doing right now. So, but like I said, on like an AP exam, they're really, I don't think they've ever actually gone that many. I think they said like second or something like that. Okay. I think they'll say second or maybe even a third, but they'll give you what your first guess is. They'll give you C1. Okay. All right, so there we go. So I am going to go back here. Now we know C2 was equal to C1, right? Minus, so C1 was 1.5 minus control divide. Now this is important right here. This vars button right here next to delete. Vars, I'm going to use my first function, and that was 1.5. And go down, vars, my second function, and I'm going to do 1.5. So this right here is going to save you a lot of headache, because after this, I'm going to get a decimal approximation. And trying to plug in that decimal is a pain over and over again. So we're telling the calculator to do it for us. Now, this is the answer for what? C2. 125,714. Hold on. 7, was it 1.4? Something like that, right?
No, the 5 was 6.
125,714. Did I get it wrong? No? I got it? Okay, so that's my C2, right? So to find C3, I need to enter C2, right? Watch this. Come on. Highlight, enter. All you have to do is arrow up and hit enter when it's highlighted, and that's going to copy that down. Minus, control, divide, F1 of F2 of You can?
Yeah, with the negatives. Or, yeah, the negative sign.
So control, answer.
Yeah, when you press enter, it just becomes
It becomes what it was? That's a neat trick. I haven't done that one before. Hey, it does. And so this represents what? C3. So 120758. And we're looking for C4, right? Now, if you notice, I'm writing a whole lot of digits here. Why am I writing more digits than I need to? In AP Calculus, how many digits do we always round? We always round 3. But we're not rounding yet. If we round at the beginning, it's going to be further and further away every single time we use that number. So we're not going to round until the end. So even in the instructions for the AP book, it says do not round your answer until the end. So C4. Now I'm going to try that trick now. So it's going to be answer. So control there minus control divide. Man, you just like seriously made my life like I was today years old when I realized this. You are there we go. 120557. What's slowly happening from here? As I keep getting closer and closer and closer, I started off with 1.5, didn't I? That was a guess. My next one went 1.2, right? And went to 1.25. The next one went 120. Now it's still 120. And so every time I do another iteration, I'm getting closer and closer to the exact answer. So my 0 first one didn't take. That's the lower bound. Right there, upper bound, there. And I'm going to hit this here. This is a little bit easier. So we found the exact answer. The exact answer comes out to 120557. And if I was to round that to the third decimal point, it would be 120. Wrong. Because you round to the third, right? So that 5 is going to make that one round up to a 6, right? So 1206. Now, let's go back to my thing. So it's going to be an exact answer 1.20557, right? That's where my X is. That's where it is. If I round this one, am I going to get the same answer as I round this one? Yes. So before the calculator thing, this is kind of what they were doing. So no. You're not rounding a 4. my answer that you're going to put down, you're going to say C4 is approximately 1206. Umbridge?
Does it eventually get you the answer, like the actual correct one, or is that just chance?
So, going to the fourth got me the same answer as what I would have rounding it 3 decimals, right? So if I had to round it 4 decimals, should I go one more? If I was going to go 4 decimals, I would actually have to do one more iteration.
Okay.
Does that make sense?
Yes.
There we go. All right, let's see. I think that's it. Oh, okay, graphing. So more calculator. Use intermediate value theorem to confirm that f has a 0 in the interval from 0 to 1. Now, to confirm that it has a 0 between 0 and 1, what's got to happen? Crosses. Okay, but mathematically, I would do what? It's got to have what? There we go. Positive and negative. So it's got to cross there. So intermediate value theorem for that says that there's going to be 0 in between there. So let's do f of 0. So f, I'm going to change colors because it's a little bit brighter here. So f of 0 is what sign at 0? 0. Okay, 0 squared? Okay, f of 1. One. What's sign at 1? It's some weird decimal. Plus 1. Is it a positive decimal or a negative decimal? It's going to be a positive, right? It's going to be a positive. So this is going to be 1 point, blah, 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 blah. But it's positive. All right, can I confirm that this has a 0 here? No, why? There's no change. There's no change. So that's where this one fails. So it only works if it crosses, and I have to test it first because I'm pretty sure everyone would be looking at it and be like, all right, I'm going to do blah, 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 and jump right into it. You have to test it first. It is going to fail.
But because isn't it touching the x-axis because it is 0? Isn't that still technically 0?
What is that? It's a, okay, what does a parentheses mean in this sense? It does not include 0. So it's close to 0, but it does not include 0. So I can't really say yes or no.
How do you know it doesn't cross later on?
Remember the chicken crossing the road?
Yeah.
Okay. Yeah, I'm just using those 2 points. So if I have a start here and I end there, it guaranteed to cross the road. But if I start here and I don't end over there, I could have crossed it 14 times. But using intermediate value theorem, I cannot prove that I crossed the road. Okay? Now, let's go ahead and try this out with the calculator here. So, now, with your calculator, because I love teaching calculator, and because I just learned some more stuff. So watch this. I'm going to clear out all this. Doc, letter B. That clears it. My thing was sine of, was it sine of x?
Yeah.
X
Plus x squared.
There you go. Yeah, and from 0 to 1, does that work out? No. So these methods do have places in which that they fail. So you have to be careful and check everything that you know in the first place. Okay, for this to work out, there must be a 0 in between there, and there. So you have to look at your interval that you're using.
But didn't we find a derivative?
We did. Okay, first thing I did was, is there a 0 in between there?
Yeah.
So Newton's method requires the function and the derivative. But for the Newton's method to work, what had to happen? There had to be a 0. So there had to be a change somewhere in between my interval, right? There's no change in the interval. Can I use that method? No. There we go. Make sense? Okay. So, and it shows right here it actually doesn't work out. Anyway. All right. I think that's it. Like, share, and subscribe.